So here's the deal, all right? I know. You should always show a problem being solved when doing any introduction. Okay, I'm a firm believer in this, all right? But when I'm at home, I'm not really thinking clearly. When I'm off for several days at a time, I'm not thinking clearly. So I ask for your forgiveness. Now, without further ado, let's talk about some of these speed and distance problems that we've been dealing with last couple days, because we're going to do a lab over them tomorrow. Anyway, you will see that video as well. That lab will be Thursday. Anyway, okay, so here we go. Units. When we're working with these problems, it is important to know whom you are working with and how to work with them. So let's take a look. We've got, did that help at all? Man, it's kind of weird. The white balance is strange. Anyway, meters. Meters is just like your centimeters or inches or whomever you like to say. This is a measure of distance or displacement. So if you are looking around in your problem and you see meters connected to anything by itself, that means you're looking at a distance or a displacement measurement. Now, if we go down to our little equation down here, you can see who's who, okay? X is distance, t is time, v is speed or velocity. Okay, next. S, seconds, is a measure of time. Not trying to insult your intelligence, just trying to make sure that we're all on the same page. Seconds is a measure of time, as you would expect. Now, finally, meters per second, m over s. It's kind of like miles per hour. It's a distance over a time, right? So distance over time is a measure of speed. So what we're going to do is we're going to take a look at this little thing down here and see how we can relate these three quantities. Okay, so here's this little thing down here. Of course, I make them work immediately. So x on top is distance. T is time right there. V is speed. Now, you probably saw me write this like this. V equals x over t, or delta x over t. Change in position over time. So this is a simplification. This helps you solve problems in a little bit faster fashion. All right, so let's say that, well, let's look at a problem, okay? Let's look at a problem, see how to use this, and then I'll make up something and then we'll use it again, okay? So if a car is going 15 meters per second and does so for 9½ seconds, how far does the car go in that amount of time? So we immediately start out and say, what units and what concepts do we have? What units and what concepts do we need? Tap, tap, tap. Okay, so first things first. First number we come across is 15 meters per second. We look at our unit, meters per second. We go over to our little table over here, meters per second. There she is. So what does meters per second represent? Speed. So what we can do is we can write speed, V, equals 15 meters per second. So there's our first number. Next, and does so for 9½ seconds, 9.5 seconds. We see this is a measure seconds right here. There's our unit. We go over here. Seconds is a measure of time. So that means we need to write time equals 9.5 seconds. Now, some people say my S's look like little itty bitty fives, so I'll write out sec there. And all that dust. Okay, now, how far are the first two words there? So we look at our question words and we try to determine what that means. How far? And of course, if you can think about it, how far in your life means a distance, right? So how far away am I from the camera? Well, I don't know. We could probably get a little thing here and say like, oh, it's a certain number of centimeters, like 30, okay? How far means a measure of distance. So that will be x. And when we say how far, it means we don't know it. So that means that's our unknown. That's what we're looking for. Now, what we can do with these numbers is we can apply this little triangle, okay? So you'll see what to do here in just a moment. So we're going to redraw the triangle right here so we don't mess it up in the bottom left-hand corner. All right. The next thing we're going to do is we're going to plug in the numbers we know, all right? V goes in the bottom left-hand corner. That's right here. Our V is 15. All right. Now, our T we know also is 9½ That goes in the bottom right-hand corner, 9.5. And x we do not know, so we're just going to write x. Now, how to use this triangle? What you do is you cover up what you're looking for and do what the triangle says to do. So, if two numbers are right next to each other, just like in regular old math, you multiply. If two numbers are on top, so like x over 15, let's say it was this number we knew and this one we also knew, then you will divide. If you knew this number and this number, you would also divide. So let me show you what I mean. So right here, we cover up what we're looking for, cover up the x. Are these two numbers next to each other, or are they on top of each other? So here's the two numbers that are next to each other. That means we will multiply 15 times 9 1/2. Okay? And this should give us our position. Now I'm going to take out my calculator, just as you would do in these problems. Here it is. And that'll be 15 times 9.5. Enter. We got 142.5 meters. That is the answer to that one. Okay, very good. Now let's do a different problem. Let's make up one on the fly. Okay, because we have some in your homework. I don't want to do all the ones in your homework for you. This was the first one from your homework. So hopefully that helps you solve for that one if you were unable to before. Now, let's see. Let's get in frame. Whoa. Okay, let's get in frame. We've got a cat goes 50 meters at a speed of 10 meters per second. This problem's easy. Sorry, the numbers are really nice. Not usually that way. A guy goes 50 meters at a speed of 10 meters per second. What am I writing? How long is what I meant to write did this take? Okay, good job, eraser. I'm proud. How long did this take? Did this take? All right. So first thing we do is we look at our units and our numbers. 50 meters. We look at our little cheat sheet over here. Meters is a measure of distance or displacement. From our triangle from earlier, here it is. I'll redraw it. X, V, T, where X is distance. Man, all this rewriting. T is time. This video is going to be longer. V is speed. Okay, cool. So once again, we look at this 50 meters. 50 meters is a measure of distance. So X equals 50 meters. Neat. Next it says speed of. I hope that that one's a little more obvious. 10 meters per second, just for completeness. Look at the other side. Meters per second is a measure of speed. Okay, so we go back over her. We say 10 meters per second is a measure of speed. V, 10 meters per second. Then we look at our question word. How long? How long implies some sort of passage of time. So this is our question mark. So once again, we recreate our triangle over here and we put in the things, wow, it's taller now, that we know, okay? X, do we know X? Absolutely, there it is. It's 50 meters. Okay, then, next thing in the bottom left-hand corner, do we know speed? Absolutely, it is 10 meters per second. And then finally, time, we do not know, so we write our variable. So now we are looking for time. So that means we cover up the T, and then we do what the triangle says to do. These numbers, are they next to each other? Right next to each other? No. So we do not multiply. Are they on top of each other? Yes, 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 they are. So that means we would divide. So we take 50 over 10, and that will give us our time. No need for a calculator. 5 seconds. Okay, there's our time it would take for a cat to go 50 meters at a speed of 10 meters per second. So hopefully that kind of clarifies some stuff. Once again, if you look at this triangle, let's focus on the triangle just for a moment. Let's focus on this baby. If you're looking for position, if you're looking for distance, you need to multiply V times T. If you're looking for speed, you need to take distance and divide it by time. If you're looking for time, you need to take distance and divide by speed. So that's the idea. Cover up the thing you're looking for. Do what the triangle says to do. Either multiply or divide, depending on their positions. Good luck.